Bipolar ionization is another form of improving of indoor air quality and reducing your amount of your air pollutant load within the cavity of a space while people are in it. Obviously, ultraviolet light can kill airborne pathogens, but those are only ones that they can see. So how do we go about treating the space? We use bipolar ionization. By increasing the ion count in the cavity of the room that you're in, we're able to breathe and cough and sneeze, and we're contracting these types of viruses that we may have. Well, the way bipolar ionization works is it puts out positive and negative ions that attach themselves to the pathogen, making the molecule of the pathogen much heavier. Therefore, it then brings it out of the breathing zone. This is very important with systems that have negative pressure systems to be able to pull your return air through your air conditioning equipment, where there are times where we'll package both UV and bipolar ionization technologies together. But bipolar ionization is ultimately to be able to treat the air and the surfaces of the space that people are in while they're in them, such as transportation hubs, airports, railroad stations, bus stations, classrooms, large medical theaters. There are multiple examples where bipolar ionization can be used, as well as in an application packaged with another technology for things such as bioterror, killing of mustard gases and nerve gases, reducing contraction and casualty rates within these transportation hubs. So bipolar ionization is a very useful tool to reduce your indoor air pollutants and at the same time reduce the amount of air that you need to bring in to be able to bring in fresh air to the cavities of these rooms because of the indoor air pollutant loads that are caused by either humans or machines. So by being able to reduce the indoor air pollutant load, you no longer have to bring in as much outdoor air. There are standards that are written around that. Is typical building codes have 20 CFM per person of fresh air for every person that's in a space. Whereas we can reduce that to 7.5 CFM per person by reducing the indoor air pollutant load on the cavity of the space itself.